All right, so as you take a look at doing this problem, everything is given in words here. And I think we mentioned it yesterday as well. Some of you, you're going to look at the words and you're going to go straight into the math because you feel totally comfortable with the situation. And if so, that's fine. Go with it. Run with it. That's fine. But if you're looking at the words here and you're trying to figure out, what do I do with it? I just don't get it. The first thing that you should always do if you don't get a problem that's describing something that we can see, draw it. Because if you make this drawing, it makes it a whole lot easier for us to figure out. So I can draw a right triangle, because of course we're told that there is a right triangle. The hypotenuse, remember that's always opposite the right angle, or in other words, it's the longest side. So I label that one 30. And one leg, in other words, one of the others, is 18. Now, does it matter which of these two I label as 18? No. Because at this point, I don't know which one's going to be longer or shorter. But it doesn't really matter because I'm just visualizing with my picture anyway. And we're being asked to find out how long is the other leg. So I'm going to give that a name. I'm going to call it X just to be uncreative about it. All right, so now that I have my setup, I can go ahead and start plugging in. Now, I see a right triangle, and I'm trying to find the side length. That tells me Pythagorean Theorem, which we talked a lot about yesterday and was last night's assignment as well. So we're going to be doing a squared plus b squared equals c squared. In this case, that's going to be 18 squared plus x squared equals 30 squared. And so then this is what we're going to go ahead and solve through. And so we end up doing 18 squared, which is 324, plus x squared equals 900. And then, of course, we're going to need to subtract 324 from both sides. And yes, the more of this algebra that you show on your paper, the more you're going to remember it, and the more accurate you're going to be as you do this. So we end up getting an answer of 576 for x squared. But remember, that's x squared, not x. If x were 576 inches long, we'd have a bit of an odd-looking triangle. In fact, it'd be an impossible triangle. So remember, to find out what x is, we still have to take the square root of 576. And sometimes that gives us nice pretty numbers, and sometimes that gives us decimals. In this case, it gives us a nice pretty number. It gives us 24. And since in our original problem we are actually given the units as being inches, I'm going to go ahead and include that in my answer as well. So x equals 24 inches. And then that is it. That's my final answer. The whole length is 24 inches long. So this one was a lot like the type we were looking at yesterday. And our next one is as well with a little bit of a twist in it. Because we can still do the same kind of problem that we were doing yesterday, even when the numbers aren't quite as pretty. We can do it even with fractions in there. So take a moment, write down this setup, this drawing, and then we're going to start working it through and see how we can do this problem. All right, now when approaching this one, I know some of you are thinking, I'm going to make my life easier. I'm going to turn these into decimals. That could actually work out okay for you in this particular problem. But that's only because in this case, like 8/5 happens to be 1.6 exactly. It's a nice pretty decimal. Pretty soon though, I'm going to give you a problem that's not a nice pretty decimal. I'm going to be giving you problems where those decimals are really ugly, and if we have to work with those, we're going to end up with some rounding error in the middle. Our answers are going to look weird. They're not going to be exactly right. It's just going to be a problem. So we're actually going to work with the fractions specifically today. All right, so knowing that, I'm going to set up my Pythagorean theorem again, but I'm going to do it with the fractions in there. And so we're going to set it up with Pythagorean theorem. In this case, we do know both the legs. So I'm going to do 8/5 squared plus 6/5 squared. Why did I do the 8 before the 6? Personal choice. There's no rhyme or reason. It doesn't matter which one you do there first. Because between the two legs, we're adding them. And the order we add doesn't matter. All right, so right now it looks potentially intimidating, but it's actually not that bad. Because in order to square a fraction, all you have to do is square the top and square the bottom. We don't even need a calculator to square these fractions. What is 8 squared? 64. So this is going to be 64 over 5 squared, which is 25. Okay, then we're going to add. I got to do the 6/5 squared now. So 6 squared is 36. 5 squared again is 25. So we end up with 64 25ths plus 36 25ths equals x squared. Now we go ahead and do the addition. You notice the beautiful thing about this particular problem, we already have common denominators. That makes life a little bit easier. So we add the tops. That's going to give me 100 over 25 equals x squared. All right. Now, sometimes you can actually simplify at this point. In this case, you could if you wanted to, but we can't always. So I want to show you how you do it if you couldn't simplify at this point. So when we have x squared equals, we always then just take the square root of whatever it is. So we're going to take the square root of 100 over 25, and that's going to be what x is. Now remember when we squared a fraction, we just squared the top and squared the bottom? Square rooting works the same way. So I can square root the top. What's the square root of 100? 10. And I square root the bottom. What's the square root of 25? 5. Now in this particular case, you'll notice that reduces even more. I technically could have also reduced this at this point, but I wanted us to see how we could do it with the fraction still there. So 10/5 equals 2. And so x here just equals 2. And we're done. That's the final answer. All right, now looking ahead, this one happened to work out to be a nice, pretty whole number. A lot of them won't. And so a lot of them we're going to need to end up getting top-heavy fractions. And those fractions, I'm going to want us to be able to turn those into mixed numbers, because we haven't done that so far this year. So we're going to take a moment here and take a look at mixed numbers. How do we turn improper fractions into mixed numbers? We're going to start with this one. So go ahead and write down this problem. So as we take a look at turning this improper fraction into a mixed number, first of all, notice it is called improper because the top is more than the bottom. Improper is sometimes called top-heavy. So if it's top-heavy, it means we can also write it as a mixed number. Now, how to do that, I want to kind of give a visual representation to start with. So this is what a single whole, so like this is one whole here, cut up into thirds represents. So like each one of these parts of it is a third. Okay, so if I know that, then each of these little bars that I just drew here is going to represent 1/3. If I then take 14 of those and put them into a pile, this is the fraction I'm dealing with, where each one of those pieces, remember each one of these is 1/3. In order to make sense out of this chaos, I need to start grouping those together. So I'm going to pull all of these and make wholes out of them, because every 3 I can grab and I can pull them together to make a whole. Okay, so I got to find more 3s here. It's getting to be kind of a pain though, because they're all such a jumble. But it looks like that's how I can make it. It looks like I got 4 sets of 3 with a couple left over. Well, if I pull them together and organize them, then notice this. This is what we're actually looking at. This is what turning it into a mixed number really means. Is it means I'm figuring out how many full sets can I pull out of it, and then how many are left over. In this case, I can pull out 4 full sets with 2/3 left over. Hence, I can write this as 4 and 2/3. That's our mixed number. Now, visually, that's what's happening. We're just pulling all these pieces and we're trying to group them all together. The way that we do that algorithmically, that is the process, the set of steps that we go through in order to do that, is we answer these questions. We say, how many times does 3, our denominator, go into 14, our numerator? And we're talking like how many times it goes in, that's like division or multiplication into it. So 3 goes into 14 4 whole times. Now, 3 times 4 gives me 12. So that's using 12 of the 14. So how many are left over? 2. Hence, how we then pull all of that stuff together and turn that into 4 and 2 thirds. Notice the number that's on the bottom, our denominator, is the same. That part doesn't change because we're still talking about how many thirds each one of these pieces is. All right? That's the basic process of converting an improper into a mixed number. Now, just to practice that idea, we're going to go through a few here. Really quickly, please turn this improper fraction into a mixed number. All right, so for doing this one, we want to see how many times does 5 go into 21? Goes in a total of 4 times. All right, now with my remaining part, I know that it's going to be something over 5. That something is how many are left over. What's 4 times 5?
20.
20. And so it's how many are left over from that. So that means there's 1 left over in this case. So you should have gotten 4 and 1/5. So again, I want you to practice that idea with these 3. But what you'll find with these 3 is we'll also be able to bring in a couple other little nuances that come up in this. So go ahead and convert each of these 3 into mixed numbers as well now. All right, so for doing each of these, the first one, 49. How many times does 9 go into 40? Goes in a total of 4 times. Because 9 times 4 is 36. That's as close as we can get to 40 without going over. So it goes in 4 times, so it's going to be 4 and something ninths. To know that something, we say how many are left over. Well, from going from 36 to 40, it is 4. So that one's 4 and 4 ninths. Okay. In this case, how many times does 9 go into 54? Notice, knowing your times tables is going to help you out with these. It's going to make it a lot easier. Like so many things in math, the better you know your times tables, the faster and easier all stuff gets. In this case, it goes in 6 times. Because I know that 6 times 9 is 54. But you'll notice, there was nothing left over. We don't write 0 over 9. It's 6, so we just call it 6. So when you have nothing left over, it's just a whole number answer. When we say write it as a mixed number, that counts. All right, the last one. How many times does 9 go into 96? It goes in 10 times. Because 9 times 10 is 90. So then, if that is 90, that means we have 6 left over. But you'll notice my fraction in this case. This one's not done. Because 6 ninths reduces. If you wanted to, you actually could have started by reducing that as well. It's just that those were much bigger numbers. It's often a little bit easier to reduce this one. But again, as long as you reduce it eventually, which part of it you do first, it's going to work out the same. Now when we reduce it, the whole number is unaffected. So it's still going to be a 10 out front. Even if you had reduced it first, you would find it goes in 10 times. But for reducing my 6 ninths, I can divide top and bottom by 3, so I end up getting 2/3. So that's your final answer there is 10 and 2/3. When turning them into mixed numbers, yes, they still should be reduced. Same as all of our other fraction work that we have done. So this one's continuing on with the same theme. Notice, though, you will need to give your answer as a mixed number. But we start the same way. We are going to use Pythagorean Theorem. Just note which one's the hypotenuse at the start. The 34/7 is going to be your hypotenuse. And so this is our setup then. And so now we go ahead and we start solving from there. Yeah, you probably need your calculator here, but not to go into decimals, just for the squaring. And so you go ahead and square the top and bottom of each of those fractions. And then we can go ahead and work to get the x squared by itself, which means subtracting the 256/49 from both sides. And yes, it's still a good idea to be writing out your work here. It helps clarify what you're doing, even though it is quite a bit of writing in those little fractions there. And so x squared here equals 900 over 49. The last step is we're going to go ahead and take the square root of both sides. So I'm going to take the square root then of 949. Remember, take the square root of fraction, you square root the top and square root the bottom. So what's the square root of 900? Is that a nice pretty number?
30.
Yes.
30.
Gives us 30. Square root of 49, is that a nice pretty number?
7.
Yes, 7. And so there we have x equals, but we're actually not done in this case. Because of course, remember, this one specifically says to write your answer as a mixed number. So we've basically done the Pythagorean Theorem phase. So I'm done with all of that stuff. I'm now shifting into a new phase of just turning it into a mixed number. So in order to do that, we say how many times does 7 go into 30?
4 and 2.
And again, knowing your multiplication tables here makes it a whole lot easier. It goes in 4 times. So it's going to be 4 and something sevenths. 4 times 7 is 28, which means we have 2 left over. So it's going to be 4 and 2 sevenths. That is our final answer then as a mixed number. Now in this case, we're looking for our hypotenuse. So the math will actually probably be a little bit easier in its own way. We'll go ahead and work it out from there. All right, we work it out through, we get the x squared equals, and then we take the square root of both sides. Now the square root is 676. Yes, that does give us a nice pretty number, that's 26. Square root of 121 is 11. And so x here equals 26 over 11, or, remember we need to give our answer here as a mixed number. So, how many times does 11 go into 26? Twice. So that's going to be 2, because 2 times 11 is 22. So how many are left over? 4. And so there's our final answer, 2 and 4 elevenths.